This is Mrs. Zappia with Lesson 4 from Module 5, Grade 7, Calculating Probabilities for Chance Experiments with Equally Likely Outcomes. Student outcomes for this lesson. Students calculate the probabilities of events for chance experiments that have equally likely outcomes. Pause the video and copy the essential question. What's the difference between an event and an outcome? What does it mean to choose a cube at random? All items, cubes in this case, are equally likely to be drawn. In this case, it might mean the cubes are all the same size and shape. At random means all have an equally likely chance of being drawn. What does it mean to draw a cube with replacement? Once a cube is drawn, it is replaced before the next cube is drawn. So you draw a cube, you replace it, and then you draw another cube. That's what it means to draw a cube with replacement. In this example for theoretical probability, in a previous lesson you saw that to find an estimate of probability of an event for a chance experiment, you divide. The probability of the event is a ratio. It compares the number of observed occurrences of the event when you do the experiment, and you divide that between the total number of observations. Your teacher has a bag with some cubes, colored yellow, green, blue, and red. The cubes are identical except for their color. Your teacher will conduct a chance experiment by randomly drawing a cube with replacement from the bag. Record the outcome of each draw in the table below. So we draw a cube, we look at it and record the color, then we replace the cube and then draw another. I conducted this experiment and here are the results. We draw yellow, yellow, then blue, then red, etc. So I did this 20 times and recorded the data. We'll answer some questions regarding this data on the next page. Based on the 20 trials, estimate for the probability of A, choosing a yellow cube. There were 22 cubes to choose from, and 4 of them were yellow. So 4 out of 20 is the probability. And remember, this is an estimate based on an experiment. We could, if we wanted to, simplify that to 1/5. B, choosing a green cube. There were 20 cubes drawn and 5 of them were green. And we can simplify that to 1/4. C, choosing a red cube. There were 20 cubes to choose from and 6 of them were red. And that simplifies to 3/10. Letter D, choosing a blue cube. There were 20 cubes to draw from and 5 of them turned out to be blue. That simplifies to 1/4. If there are 40 cubes in the bag, how many cubes of each color are in the bag? Explain. Notice that the probability for choosing a green cube and a blue cube turned out to be the same, 5 out of 20 and 5 out of 20. The other colors for red and yellow are very close to that, 4 out of 20 and 6 out of 20. So all of the probabilities turned out to be relatively close to each other. The estimated probabilities are about the same, all about 1/4. So I predict that there are approximately the same number of cubes of each color. Now there are 40 cubes in the bag, so 40 cubes divided by 4 colors is equal to 10 of each color. Number 3. If your teacher were to randomly draw another 20 cubes at one time with replacement from the bag, would you see exactly the same results? Well, what happens when you conduct multiple experiments? Would you get the same results or would you expect different results? Since this is an experiment, results will vary from experiment to experiment. Next, what is in the bag? In the bag, there were, let's move this out of the way. 10 yellow, 10 green, 10 red, and 10 blue cubes. Number 4. Find the fraction of each color of cubes in the bag. Well, there were 40 cubes in the bag, and 10 of them were yellow. There were 40 cubes in the bag, and 10 of them were green. 40 cubes in the bag, 10 were red, and 40 in the bag, and 10 of them were blue. All of these simplify to 1/4. Define theoretical probability. So we've been working with experimental probability so far, and experimental probability is the numerator is the number of times that event occurred. In theoretical probability is a little bit different. In theoretical probability, it is the likeliness of an event occurring, and it's based on the possible outcomes. So you don't actually do an experiment to find out what happens. Theoretical probability is the likeliness of an event occurring based on the possible outcomes. When all of the possible outcomes of an experiment are equally likely, the probability of each outcome, and we write that in this form. This is the probability of an outcome. So we put P for probability, and what you expect to happen is the outcome. So this is all of the possible outcomes when they are equally likely to happen. The probability for each outcome is 1 over the number of possible outcomes. Next, an event is a collection of outcomes, and when the outcomes are equally likely, the theoretical probability of an event can be expressed as, so in this example, we are talking about theoretical. And remember that theoretical probability is different from experimental probability. Experimental probability is what actually happens when you do an experiment. Theoretical probability is what you expect to happen. So the theoretical probability of an event happening is written as a fraction. The numerator is the number of favorable outcomes. And then we compare that to the number of possible outcomes. So favorable outcomes, that's what you want to happen. And possible outcomes, that is the different things that could happen. Next, the theoretical probability of drawing a blue cube. So we want the probability of blue. Since they are all equally likely to happen, getting a red or a blue or a green or a yellow, the probability is 10 out of 40. The 40 represents the number of outcomes, or the number of cubes in the bag. And the numerator 10 represents 10 blue cubes. Again, the numerator is the number of favorable outcomes, and in this case, blue is our favorable outcome. It's what we want to happen. And we could simplify that to 1/4 if we would like to. Examples 5 and 6. This refer to the bag of 40 cubes. 10 red, 10 blue, 10 green, and 10 yellow. Is each color equally likely to be chosen? Explain your answer. And number 6, how do the theoretical probabilities of choosing each color from exercise 4 compare to the experimental probabilities you found in exercise 1? Pause the video and complete 5 and 6. Resume the video when you are ready. Number 5. The answer is yes. There are the same number of cubes for each color, so they are equally likely. Okay, and we need to explain. So there are the same number of each color of cubes. And since there are the same number of each color of cubes, they are equally likely to be chosen. Number 6, how do the theoretical probabilities for choosing the colors in exercise 4 compare to the experimental probabilities in exercise 1? Now remember that theoretical probabilities is what you expect to happen based on the numbers. The experimental probability is what actually happened based on the experiment. So both of those have denominators of 40 because there were 40 cubes in the bag. The difference is the numerators. Theoretical numerator is based on how many cubes are that particular color. In experimental probability, the numerator is the number of times that particular color cube was selected. You may want to read through that a few times. Number 7. An experiment consisted of flipping a nickel and a dime. The first step is finding the theoretical probability of obtaining a heads on the nickel and heads on the dime is to list the sample space. For this experiment, the sample space is shown below. Again, the sample space is what could happen. So what could happen in this case? When you toss the nickel and the nickel could land on heads and the dime could land on heads. So one of the outcomes is heads, heads. So then you pick up the nickel and dime and you toss them. And the second time, the nickel lands on heads and the dime lands on tails. So another outcome is heads, tails. You pick up the nickel and dime and you toss it again. And this time you get tails and heads. So a third outcome is tails in the nickel, heads on the dime. The last possible outcome is that you get tails on the nickel and tails on the dime. So there are 4 different possible outcomes for this experiment. Each row is a possible outcome. There are 4 possible outcomes. They are heads, 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 tails, tails, heads, and tails, tails. If the counts are fair, these outcomes are equally likely. So the probability of each outcome is, well, there are 4 different outcomes and they are equally likely. So the probability of each outcome is 1/4. There are 4 different outcomes and they are all equally likely. The probability of 2 heads. So the probability of getting heads, heads is 1 out of 4. The probability of 2 heads is 1/4. So this is just saying it in words, and this is saying it in the symbolism for probability. So that 1 represents one of the outcomes is heads, heads, and the 4 represents that there are 4 possible outcomes. Exercise 1. Consider a chance experiment of rolling a number cube. So a number cube has 6 different sides and there's a number on each side. A. This is an exercise, so let's read through the questions and then I want you to try to answer questions A, B, and C on your own. Question A says, what is the sample space? Then list the probability of each outcome in the sample space. Question B, what is the probability of rolling an odd number? And C, what is the probability of rolling a number less than 5? Pause the video and complete A, B, and C. Resume the video when you are ready to check your work. The sample space is 1, 2, 3, 4, 5, and 6. Remember that the sample space is the different outcomes, the different things that could happen. Each one of these numbers is equally likely to happen, so the probability is 1 over the number of possible outcomes, 1/6. Question B. What is the probability of rolling an odd number? With symbolism, we write, what is the probability of odd? Remember that the denominator is how many different outcomes there are. There are 6 different outcomes. The numerator is the number of favorable outcomes. A favorable outcome in this case is a 1, a 2, or a 3. Favorable is your numerator in theoretical probability. Favorable in this case is an odd number. There are 3 odd numbers, 1, 3, and 5 on the number cube. So 3 is our numerator. We can simplify that to 1/2 if we would like to. Does that make sense that half of the numbers are odd, so your probability of rolling an odd number is 1/2? Question C. What is the probability of rolling a 5, or rather a number less than 5? A probability of a number less than 5. Remember that the denominator is the number of possible outcomes. There are 6 possible outcomes. You could roll a 1, 2, 3, 4, 5, or 6. The numerator is the number of favorable outcomes. A favorable outcome in this case is a number less than 5. The numbers less than 5 are 4, 3, 2, and 1. So there are 4 ways that you would be a winner, 4 favorable outcomes. We can simplify that to 2/3. 2/3 of the numbers are less than 5. Exercise 2. Consider an experiment of randomly selecting a letter from the word number. What is the sample space? List the probability of each outcome in the sample space. Question E. What is the probability of selecting a vowel, such as A, E, I, O, or U? And F. What is the probability of selecting the letter Z? Pause the video and complete these exercises. Resume the video when you're ready to check the work. The sample space is the different number, or the different letters in the word number. N, U, M, P, E, and R. So there are 6 letters in the sample space. The probability of each outcome. Each letter is equally likely to be picked, so the probability of each outcome is 1 over the number of possible outcomes, which is 6. Letter E, the probability of selecting a vowel. And remember, the vowels are A, E, I, O, and U. The denominator is the number of possible outcomes in the sample space. There are 6 letters that could be chosen. How many of them are vowels? U is a vowel and E is a vowel. So there are 2 favorable outcomes. Remember, in theoretical probability, the numerator is the number of favorable outcomes. In experimental probability, the numerator would be the number of times that a vowel was chosen. Letter F. What is the probability of selecting the letter Z? How would you write that with probability symbolism? You would use probability parentheses Z. The denominator is the number of possible outcomes. there are 6 possible outcomes, the different letters in the word. The numerator is the number of favorable outcomes. A favorable outcome in this case would be to get the letter Z. There are no Z's in the list, so you write 0 Z's. And so your probability of getting a Z is 0. Do you remember what that's called when the probability is 0? It was called impossible. Exercise 3. Consider an experiment of randomly selecting a cube from a bag of 10 cubes. Color the cubes on the right so that the probability of selecting a blue cube is 1/2. Question B. Color the cubes on the right so that the probability of selecting a blue cube is 4/5. If you have colors, go ahead and use your blue. If you do not have any colors, you can use a capital B for blue in the box. Pause the video and complete A and B. All right, so we want the probability of 1/2. That means that half of the cubes will have to be blue. Since there are 10 cubes altogether, we need half of 10 to be blue, and half of 10 is 5. So we have 1, 2, 3, 4, 5 blue cubes. And it doesn't matter which 5. Next, color the cubes on the right so that the probability of selecting a blue cube is 4 out of 5. So 4 out of every 5. Well, we have 10 cubes, so we'll need to use a proportion. 4 out of every 5 would be how many out of 10? Well, let's take a look. If we have 1, 2, 3, 4, 5, and 4 out of 5 is blue, so that would be blue, 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 and blue. And then we'll leave that 5th one alone. And then for the other group, we have 1, 2, 3, 4, 5. And 4 of those are blue. So we have blue, 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 and blue. So 4 out of 5, how many blue is that altogether? That's 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 10. So we should have 8 out of 10 blue cubes. And then the others would not have anything in them. Exercise 4. Students are playing a game that requires spinning the 2 spinners shown below. List the sample space and the probability of each outcome in the sample space. A student wins the game if both spins land on red. What is the probability of winning the game? Let's get started with listing the sample space. So I'm going to make 2 columns in order to organize my sample space, and I prefer columns rather than rows for this activity. So you can organize yours how you like. So I'm going to have my first spin and my second spin. In my first spin, I could either get red or blue. And I'm just going to start and list all the combinations that could happen if I get red on the first spin. So if I get red over here, and then I come over here and I spin and I get red. So one combination is red, red. Now let's say I get red on the first, and then I spin the second one, I could get blue. So another combination would be red, blue. Another combination would be red with green, red and green, and a fourth combination would be red with yellow, red with yellow. So those are all of the combinations if I get red on the first spin. Okay, I'm going to erase these and I'm going to start over and I'm going to repeat the process for if I get blue on the first spin. So if I get blue on the first spin, that would be blue, and then I get red on the second spin. So that combination is blue, red. Then I could also get blue, blue, B, B. I could also get blue, green, BG, and I could also get BY, blue, yellow. Those are the different combinations that I could get. I could get red, 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 blue, red, green, red, yellow. Or I could get blue, red, blue, 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 green, and blue, yellow. So those are all of my outcomes, and that is the sample space. D. A student wins the game if both spins land on red. What is the probability of winning the game? So we can write capital B for probability, R, R. And that stands for, what is the probability of spinning red, then red? Remember that our denominator is the number of possible outcomes. So there are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 possible outcomes. The numerator is the number of favorable outcomes. A favorable outcome is what you want to happen. Well, I want red, red. How many red, reds are in the list? Red, red is in the list only once, so my numerator is 1. And that's the probability of winning the game, 1/8. Let's summarize what we've learned in this lesson. An outcome is a possible result. Outcomes of flipping a coin, you could get heads or tails. An outcome is what could happen. An event is flipping a coin and it lands on tails. An event happens. Sometimes students get confused about what's the difference between an outcome and an event. Don't worry too much about that. As we work with probability, you'll get used to the terms and you'll discriminate which is an outcome and which is an event. When all the events are equally likely, such as flipping a coin, the probability of each outcome can be written as a fraction. It's 1 over the number of possible outcomes. For example, flipping a coin. The probability of each outcome is 1 out of 2. 1/2 of the coin is heads, 1/2 of the coin is tails. Finally, when all outcomes are equally likely, the theoretical probability. Now remember that theoretical probability is what you would expect to happen based on the number of items. When all items are equally likely, the theoretical probability, that's what you expect to happen. Okay, so it's written as the probability of the event is equal to the number of favorable outcomes over the number of possible outcomes. And again, you'll get used to these terms and the ways of writing the probabilities as we practice each day.